Solving percentage problems. So we're going to talk about lesson 14 here, and we're going to solve some more percentage problems. Yes, we've talked about some of those. Today's I can choose and create diagrams to help me solve problems about percentages. So we're basically going to be doing a similar thing to what we've done before. We'll also talk about ways you can set up things to be able to solve those particular problems. So once you have today's date, your I can statement, and your page number, then you are ready to go on. We're going to do a quick number talk about multiplication with decimals. Okay, so I want you to try and figure these out in your head. We have 6 times 8/10 times 2. Okay, so several ways you could have done this. You could have taken the 2 times the 8/10 first, or 2 times the 6, or 6 times the 8/10, or however you wanted to arrange those things around. Because remember, with this, it's about using the commutative property, and you can move things as long as everything is multiplication or addition. You can move them around however you want to solve them out if they're all the same operation. With multiplication and addition especially. You can sort of with division and subtraction, but it's very tricky. Let's see, 6 times 8/10 will give you 4 and 8/10. 4 and 8/10 times 2 would get you 9 and 6/10. What about this other one? Okay, so I probably would have done 4 times the 6/10. That would be the quick thing to think of, right? You get 2 and 4/10. But probably you're going to do a better job, because I know I've got a 5 here and I've got a 6 here. So that's going to give me a 0 at the end. And I always like to find zeros when I can. So 6/10 times 4 and 5/10. 6 times 5 is 30. Carry the 3. 6 times 4 is 24, plus that 3, that's 27. And there's a 0. 270. 270, we've got tenths and tenths. So it'd be 2 and 70 hundredths. 2 and 70 hundredths times 4. Let's see, that would be 28. Carry the 2. And then you would have, wait, what did I just say? Yeah, 8. Carry the 2. 4 times the other 2 would be 8, plus the 2 would be 10. So it should be 10 and 8/10. I'm going to actually have to work this one out just to make sure. There is nothing wrong with doing a problem mentally first, and then going back and writing it out to double check yourself. Oops. 2 places to the right, so it should be 2 and 7/10. All right, 2 and 7/10 times the 4. Yeah, 10 and 80 hundredths are 10 and 8/10. Okay. And again, decimals, all of this leads us into percentages. And when you're talking about percentages, a lot of times you're thinking of those parts. We talked about in the last lesson about fractions, and decimals are just another type of fraction. So we're going to look at some coupons here to figure out some prices. So there are all kinds of coupons. Sometimes they have just a straight like $5 off, or 25 cents off the purchase of 2, or something. There's all kinds of different ones. The percentage ones, though, are where it gets a little trickier. So Han and Claire go shopping, and they each have a coupon. Let's see if we can answer both of these. Han buys an item with a normal price of $15 and uses a 10% off coupon. How much does he save by using the coupon? Well, first thing you need to do is you need to figure out what 10% of 15 is, right? And you can draw out a chart. If we know that 100% is $15, what's 10%? It's 1 and 5/10, right? So it says you're going to take off 10%. So what we're actually going to do is we're going to subtract that 1 and 5/10 off of the 15 to find out what the actual price is. But it says how much did he save. So we only need to know that he saves $1.50. Okay. Claire buys an item with a normal price of $24, but saves $6 by using a coupon. For what percentage off is this coupon? Is this still going to be 10% off? No, it's actually going to be more, right? Because if we think about it, even if we're just looking at it as being $24, if it was 10%, you're moving those place values just one place smaller by that 10%, and saving that much, not going to be 10%. It's actually going to be more than 10%, right? Because 10% of 24 would be $2.40. So $24 is here, and that's 100%. And I know I've got it opposite of the way I did up there, but I've got everything labeled, so I know what I'm doing. Yes, I do. All right, there's our percentage and their cost. Okay, so we want to go from that 24 down to 6. So how do you get to 24 from, how do you get from 6 to 24? Yeah, it's divide by 4, right? So what's the percentage that would be equivalent to 1/4 of 100? Yeah, it's 25%, right? And how do I know it's 25%? Well, remember we talked about with fractions before. If you have to take 24 and divide it by 4 to make 6, you're going to have to do the same thing with this other part of the double number line, right? So you're going to take 100 divided by 4, you get 25. So in this case, we found out that it was 25% off. So she's actually getting a better deal. Try one other one here. Claire paid full price for an item. Han bought the same item for 80% of the full price. Claire said, I can't believe I paid 125% of what you paid, Han, is what she said. True. Okay, well, if Han paid 80%, that's 80 out of 100, right? Claire said she paid 125% of 100. Well, let's see here. 80%, let's reduce this down, gets us 8/10, and that would make 4/5 the price, right? Okay. Claire paid 120. She says that she paid 125%. Well, that means that she paid the whole price and paid 1/4 more than what Han did. Well, quick look at this. This looks like it would only be 20% difference, right? Because 100% minus 80% would get you 20. So that would seem right. But here's a reason why it's not. Let's divide this out. Okay, so both these I can divide by 25, right? This has got 25 in it. I can actually divide that by 5, or divide it down to 5. And divide 100 by 25 would give me 4. So she paid the full price, plus 25% compared to what Han did. Is what she said actually true? It is, because she paid 4/4, which would have been 100%, and she paid 1/4 more, or 25% beyond the 100% to equal the same price that he paid. Now, does that mean that 4/5 is equal to 5/4? No, it's just talking about the percentage comparing how much they paid. So if she paid the full price, she paid actually 125% more than Han, or 125% of what Han paid. So she paid all that Han paid and paid 25% of beyond what he did. Does that mean these percentages have to equal each other and add up to 100%? No, because you're looking at different parts with them. All right, let's talk about some music devices. Okay, so store sells 3 different types of devices. We've got device A, which is $15, device B, which is $25, and device C, which is $40. Jada has 60% of the money needed to buy device C. So, which of the devices can Jada afford? Hang on, let me make this bigger. There we go. Okay. So, what do we got going on? Well, which device can Jada afford? We have to figure out 60%, right? 60% of C. We know 100% is 40. We want to get to 60%. Probably can't make that straight jump, can we? So we need to come back to something that is going to be something that we can see in parts. Well, if I make this go back to 20%, because 20% I can make it into 60 by multiplying by 3, right? So let me go back to 20% of 100. So what would 20% of 40 be? Well, you have to go from 100 to go down to 20, you have to divide by 5. So I have to take 40 and divide by 5, which gets me 8. So now I know 20% is 8. So that means that 60% of that $40 would be 24, right? Because I would take from here to here, I have to multiply by 3 and multiply by 3 here. I could have taken it down to 10% or 1% and done that. This is just what I chose. It was the easiest numbers that I could see. Nothing wrong with doing any of those other percentages. This is just what I chose to use. So she's got $24. Can she get any of them? Yeah, she can get device A, right? What percentage of the money is needed for, does she have of device B? Hang on. Well, I'm going to go kind of a different way. I'm going to go with, I think I'm going to divide both of these by 25, because it should give me to some whole number that's fairly easy. So 25 divided by 5, or 25 is 1. 100 divided by 25 is 4. So I want to get up to 24, right? So how do I go from 1 to 24? Again, this is, remember that when we talked about before, that those unit numbers can come in quite handy at some points. Just kind of depends on what the situation is. And, in the previous situation, we didn't need to. On this one, we definitely need to. So 24 times 1 gets us 24. 4 times 24 gets us 96. So she has 96% of the money. So when we're talking about percentages, you can, if you know these 3 pieces of information, these are going to be the piece of information you're going to need for 3 different types of questions. First one here, we got 20% of a 400-liter tank. What is that? That's going to be 80, right? Because to go from the 100 to the 20, you divide by 5. So same thing, you're going to divide by 5 or multiply by 1/5. 20% of the full tank is 80 liters. How many liters is the full tank? Well, now we know that if we're going to go from 20% to 100% of the tank, you have to multiply by 5. So you're going to multiply by 5 to get the full, which is the 400 liters. If we know that 80 liters out of 400 liters, what percentage is that? Again, it's about knowing how you're converting those pieces, and a double line graph is a great way to set up to see these sorts of things. And you're just dividing by 5. And, you know, we could use this double number line for all 3 of those pretty easily, because once we know one of the two of the 3 parts, then it's easy to figure out the other pieces. You know, tables are also great. Tables, you know, in some ways can be quicker to organize and such. All right. So we were just talking about the different types of diagrams that we could use to solve these particular problems about percentages. Thanks.